welcome back. It's the last section of the quadratic chapter. We're going to be doing solving quadratic equations by finding the square roots. Awfully exciting. We're also going to be looking at the dark side of these algebras. And to start off, we have not Bane, but Bean. Alright, and my favorite Bean quote here from his last movie. Let's take a look.
Bane, let's not stand on ceremony here. Mr. Wayne. Peace has cost you your strength. Victory has defeated you.
Alright, so let's get to it. A couple of things. A square root. A number r is a square root of a number s if r squared equals s. Alright? So for example, 3 squared equals 9, and negative 3 squared, because negative times a negative is a positive, equals 9. So 3 and negative 3 are square roots of 9. A lot of times when we're talking about simplifying, we're just going to be talking about the principal square root, which is the positive square root. So for example, if I wanted you to find the square root of 16, you would just tell me that that square root is 4, because we're just dealing with the positive, the principal square root. All right, let's talk about these things. So this sign here, this is called a radical. It's the operator to take the square root. It tells you to take the square root. All right, remember, 3 squared, what number times itself equals that number essentially? So the square root of 9, what number times itself equals 9? Well, 3 would be the principal square root, negative 3 would be the other root. And the radicand. The radicand, that's probably a new one for most of you, is the expression under the radical. So whatever's in here, most of the time it's going to be numbers, but it could be variables or whatnot. That's called the radicand. And very important, radicals are simplified if 2 rules. No radicand has a perfect square factor other than 1. So for example, if I have 16, I need to write 4 because that's a perfect square. 1 is really the only one that we could leave under a radical, all right? But that's just because, for example, if you were dealing with variables, that's a 1, and you can always have a 1 under things. You're really going to see this, most of the time, you'll do the square root of 1 is 1. And there is no radical in the denominator, so you can't have a radical down here in your denominator, all right? So a couple of things, we're going to be simplifying radicals. I'm going to do this as a review. Again, I expect you to know this from Algebra 1. If you don't remember this from Algebra 1, more in-depth review, go to Algebra 1 at flipmath.com. It's in section 12.1, all right? So the first thing over here we have our numbers, and then we have our numbers squared. All right, these are the perfect squares, the first 15. So for example, square root of 225 is 15, all right? Some of you may want to write that down. Some of you are pretty good with them. So here's what we want to do. We want to simplify. We can't have any perfect square factor under here. So now 80 is not perfect. 81 is. So we're looking for factors of 80 that are perfect squares. Well, is 64 going to 80? No. 49? No. 36? No. 25? No. 16? Yeah. So this is 16 times 5. 5 is not a perfect square, so I'm going to leave it. But 16 is a perfect square, so I take it, and it's 4 radical 5. Okay? 2 radical 40. So I look here, 40, 36 doesn't go in, 25, 16, 9. 4 is the first one, so this is the same thing as the square root of 4 times the square root of 10. Square root of 4 is 2, so this is 2 times 2 radical 10. If you take it out, you always multiply it. And so that is 4 radical 10. All right, so that's just simplifying. Quick refresher on simplifying. So now let's do multiplying and dividing. When we multiply, if it's outside, you multiply with what's outside. 2 times 3 is 6. If it's inside, we multiply it on the inside. 5 times 10 is 50. And of course, if you can simplify that, you definitely need to simplify it. And 50 comes over here. 49, no, 25. So this is the square root of 25 times the square root of 2, because 2 times 25 is 50. Square root of 25 is 5, so 6 times 5 radical 2, that's 30 radical 2. When you have a division or a fraction in here, you are allowed to do the same thing I've been doing with multiply. Split them up. And remember, we can't have a radical in the denominator. Since it's a perfect square, that's 5. The square root of 4 is 2. Not too shabby. Now the one that's kind of tricky for people, it's rationalizing. See, 10, it's not like this one where the square root of 25 was a perfect square. 10's not a perfect square. So what I'm going to do is I'm going to multiply. I'm going to take whatever's in this radical here and multiply the top and the bottom, because that's essentially the number 1, right? And I can multiply 1 by anything, it doesn't change anything. So 5 times radical 10 is 5 radical 10. On the bottom I have radical 10 times radical 10, which is radical 100. So now I have 5 radical 10 over the square root of 100 is 10. I always want to look, can I simplify? Yeah, 5 goes into 10 twice, so that's going to be radical 10 over 2. All right? This one's definitely new for you guys. It's called rationalizing with conjugates. Here's conjugates. Conjugates are two things that when you multiply them together, you're going to get just a rational number. All right, it's going to be nice. It's not going to have any radicals in it. Let's take a look and see why. And this is kind of like difference of squares. A times A is A squared. A times negative radical B is negative A radical B. Radical B times A is A radical B. And then radical B times radical B is, times negative radical B is negative radical B squared. All right, so these cancel out, so I'm left with A squared minus, and the square root now of a perfect square, it comes out. So it's gonna be gone. There's not gonna be any radical left. Why do I need to know what conjugates are? Let's take a look down here. I have a radical on the bottom, so if I do what I normally do, I multiply the top and bottom by the radical. Radical 4, that's good, but I have to distribute this, so that's 7 radical 2. Now I'm in the same spot. It does me no good. So what I need to do is multiply by the conjugate. So right now I need to understand I have a positive and a negative conjugate. They are, opposite forces. So I'm going to pick the opposite one. I have plus, so I'm going to multiply by 7 minus radical 2. And I do it on the top and on the bottom. So 3 times 7 is 21. 3 times negative radical 2 is negative 3 radical 2. On the bottom, I have 7 times 7 is 49. 7 times negative radical 2 is negative 7 radical 2. 7 times radical 2 is positive 7 radical 2. And radical 2 times negative radical 2 is negative radical 4. All right? So on top, there's nothing I can do. I can't combine these things because they're not the same. On the bottom, these cancel out, and I know the square root of 4 is 2. So it's 49 minus 2, which is 47. And there you have it. Over here, it could get a little bit more tricky. Now, I don't care about radicals on top. I'm allowed to have that. So I'm not going to multiply by this conjugate of 3 minus radical 7. I'm going to multiply over here. I have a minus. I'm going to do 2 plus radical 10. If I do it on the bottom, I have to do it on the top to keep things balanced. That's really just like multiplying by 1. So 2 times 3 is 6. 3 times radical 10 is 3 radical 10. Radical 7 times 2 is 2 radical 7. And radical 7 times 10 is radical 70. On the bottom, 2 times 2 is 4. 2 times radical 10 is 2 radical 10. Negative 10 times 2 is negative 2 radical 10. And negative radical 10 times radical 10 is negative radical 100. So on the top, is there anything I can do? 10 simplified 7 simplified 70. Is there a perfect square that goes into 70? Well, it's 35 times 2, so no. So 6 plus 3 radical 10 plus 2 radical 7 plus radical 70. I can't combine any of them because they're all different. On the bottom, I know this cancels out. I know the square root of 100 is 10. So 4 minus 10 is negative 6. Let's solve a couple quadratics now, and this is when when b equals 0 we can do this. So in other words, there is no x term, right? ax squared plus bx plus c. There is no bx term, okay? All right, here we go. That was kind of crazy. When I simplify, I do my order of operations straight down. When I solve, I generally do them backwards. So right now I have an exponent, I have a multiply, and I have add 5. So I want to go backwards. The opposite of adding 5 is subtracting 5. So now I have 3x squared equals 36. Opposite of multiply by 3, divide by 3. X squared equals 12. The opposite of squaring is taking the square root. Now in this case, I can have two answers for this. Alright, so the first thing I'm going to put is plus radical 12 or minus radical 12. So let's simplify radical 12. That's radical 4 times radical 3. So I could have 2 radical 3 or negative 2 radical 3. And a lot of times you'll write it like this, but shorthand, plus or minus 2 radical 3. That's just shorthand to let you know that you could have the positive or the negative of that. Let's go over here. On this one I have multiply and grouping and exponents. So let's see. I have grouping, I have exponents, I have multiply. So I'm going to start with the multiply. Here we go. The opposite of multiplying by 1/5, I'm going to multiply by the reciprocal. It's the same thing as dividing by 1/5. Multiply by the reciprocal. So now I have g plus 3 squared equals 35. Now I have grouping, that's last, so I have to take the square root of both sides. So I have g plus 3 equals positive or negative square root of 35. Can I simplify 35? Well, it's 7 times 5, and neither of those are perfect, so I'm going to leave it. Now I have the opposite of plus 3 is minus 3. You could put it at the back. For some reason, I like putting it at the front. So it's negative 3 plus or minus the square root of 35. So this one's a little bit trickier, but not much. I have, I have subtraction and I have division. So the opposite of minus 6 is plus 6. So I have x squared over 25 equals 4. Opposite of divide by 25 is multiply both sides by 25. A lot of you guys freak out when you see fractions and you automatically assume you can't do it. Yes, you can. Opposite of square, take the square root. So x equals, and don't forget plus or minus 10. Over here we have a ton. We have minus 12. We have multiply by 2. We have grouping. We have exponents. So let's start with subtraction. The opposite of minus 12 is plus 12. So what's left over here? I have 2 times the quantity x plus 2 squared equals 64. Divide both sides by 2. X plus 2 squared equals 32. Take the square root. So now I have x plus 2 equals the square root plus or minus the square root of 32. I can reduce that, right? Because 16 times 2, so that's 4 radical 2. So now I'm going to subtract 2 from both sides. So I have x equals negative 2 plus or minus 4 radical 2. So over here we have Bruce Luther standing at the top of a 300-foot tall building above an unsuspecting Superman. He plans to drop a piece of kryptonite on the Superman and he just needs to know how long it will take to land. So we have an equation here. This equation is for any dropped object, so you're going to use this in your applications. We have the height we want to know equals negative 16 times time in seconds squared plus h sub 0. H sub 0 means our initial height. Quick thing in science and all that stuff, when you have a subscript of 0, it means initial. That's your initial height, all right? So, before we get into this, I wanted to know, why can Lex Luthor, this normal guy, why is he able to be the villain to Superman, this, invincible guy? How can this guy beat Superman? And here's the answer.
You diseased maniac. Do you really think you could hide it from me by encasing it in lead? I'll mold this box into your prison bars. Don't touch that.
I told you. It's kryptonite, Superman. Little souvenir from the old hometown. I've spared no expense to make you feel right at home.
So he tricks him. Yeah, Superman apparently not super bright. Anyway, so we want to find out how long it's going to take that kryptonite to land on the ground. The ground is 0 feet, so our height that we care about is 0. Negative 16 t squared plus our initial height is 300. So I'm going to solve for t. I'm going to subtract 300 from both sides. Negative 16 t squared equals negative 300. I'm going to divide both sides by negative 16. And then t squared is going to be about 18.75, and take the square root. Now, since this is an application, I don't want to break this down. I want to actually get an approximation. And if I put that in, the square root of 18.75 is about 4.33 seconds. So it'll take about 4.3 seconds for that kryptonite to fall to the ground. So pause the video, do these two. Alright, here we go. So I need to multiply by the conjugate on this one, on top and bottom, and I have minus, so I'm going to do 3 plus radical 2, top and bottom. So 5 times 3 is 15, 5 times radical 2 is 5 radical 2. On the bottom I have 3 times 3 is 9, 3 times radical 2 is plus 3 radical 2, negative 2, radical 2 times 3 is negative 3 radical 2, and of course negative radical 2 times radical 2 is negative radical 4. We know these are going to cancel in the middle, and we know this is 2, so 15 plus 5 radical 2 over 9 minus 2 is 7. Over here, I'm going to add 6 to both sides. So 1/3 x plus 2 squared equals 12. Multiply by the reciprocal, multiply by 3. X plus 2 squared equals 36. Take the square root. X plus 2 equals plus or minus 6. And then subtract 2. So in this case, we really can combine these. So I have 6 minus 2 is 4. Or I have negative 6 minus 2 is negative 8. And that time we got rid of all our radicals. Best of luck on finishing up this chapter strong. I will see you on the flip side.